Okay, let's look at the problem. So what do we have here? By the way, just the fact that you have a grid means is it 1D or 2D? 2D. It even says what? Perpendicular case and 2D. Okay. So question says Jill and Jack are siblings and they're training for a race. Okay. So neither of them does things the way the other does. Okay. Everyone has to have their own thing. Okay. So they're training, uh, but they're at least starting what from the exact same starting point. Okay. So Jill has her training route, the way you say it. They both start from here together. However, how does she go? She goes, he goes easy, 10 kilometers west, 8 kilometers north, and finally he goes back 6 kilometers east. She does a more complicated one, 6 west, 7 north, 5 east, 2 north, 3 west, and 1 kilometer south. Amazingly, they both take 2.5 hours to travel whatever routes they actually travel. Okay, question number one, or question A. Sketch the route of each one. So who needs rulers? Okay. So basically, just like we did with the other worksheet, trace the root of each one. Okay, so go ahead. Okay, okay, go ahead. I'll do it for you as well. So who is the first one we're going to start with? The easy one. And the easy route is actually taken by Jack. So he goes, how much does he go on west? 10. So you count, obviously, we're using the regular compass. And the regular compass is east, west, north, south, the same way as we always do. So we do 10 kilometers west. Then what? We do 10 kilometers west. Then what? 8 kilometers north. So on a map, we would just go straight up. Come on. All right. And then what? 6 east. So we're going to retreat back 6 squares. Okay. So that will be the end of where Jack actually stops. And apparently it takes him 2.5 hours or 2 hours and 30 minutes. All right. Now for Jill's path. Well, Jill actually, she at least goes with him at the beginning. So she still goes west, but she only goes 6 kilometers. And then what does she do? She does 1, 2, 3, 4, 5, 7 north. And then what? 5 east, 2 north, 3 east. Not coincidence. They perfectly end up where? Exactly at the same spot. They perfectly end up at the same spot. I just worked out the problem this way. So go ahead. So okay, so what's the first part? So the first part is saying what? On the grid, trace the route, done. They know the ending point by end. Please always do that. And then to the left of the grid, okay, indicate the scale used. What does it mean, indicate the scale used? What's a map scale? Yeah, apparently each square is a what? Is a kilometer. So go ahead, just next to it, just write 1 square, 1 SQ, never write square. 1 SQ equals 1 kilometer. Okay, 1 SQ equals 1 kilometer. Okay, Sally, would you mind reading part B for us? Listen carefully, everyone. Go ahead. So the question is saying what? After tracing, how far apart did they end up? Did they end up far apart at all? Okay, what's the second part of the question? Go. Did they both move the exact same way? So to an active observer, are they the same? However, did they both start the same spot? Did they both ended up at the same spot? So to a passive observer, they are the what? They are the same. So what does that mean? Is their distance or is their displacement the same? Perfect. There you go. So the answer to the second question is, so what are we gonna say? We can say they ended up at same location. Therefore, therefore, since since their since their what? Initial and final since they're initial and final position, not displacement, position. In other words, there's no such thing as initial and final what? Displacement. There's initial and final what? Position that gives you a displacement. Their initial and final positions are the same. Their displacement. Their displacement are the same. Done. Okay. What's the first step you do if you're trying to find 2D displacement? 2D displacement. What do you do to the grid, or what do you do to the shape? So you create the what? You finalize the triangle. Okay. So let's look at it. My triangle. Again, what do I connect first? Always. You need to you need to connect initial and final to make your what? Your hypotenuse, and then you create the what? The sides of the triangle. So, oops, no, I'm good. Oh, sorry. All right. So go ahead, everyone, and connect. I guess it's right here. Yep. So go ahead and connect. Start to end. Again, why do we use dashed lines? Because they did not really what? They did not really happen. They did not actually take place in the physical world. These are just the mathematical imprint I put on the problem. Okay. So I guess I have my. By the way, where is my other triangle? I mean, most of the time, probably we're gonna use something like this. Where is the other one? You can always create two triangles in a box. Where's the other one? Yeah, exactly. It's basically, sorry, it's this one. This one. I will usually use the other one. Okay, doesn't matter. Okay. All right. Now let's actually start with the math. How big is the base of this triangle? 4 squares, 4 kilometers. And how high is the vertical side? Is it 9? I know. Count. Just count. How many people go with 8? It is 8. All right. So let's go here. And what do I sketch on this side? The triangle. Extract it from the busy diagram and just sketch it right here. Okay. So here it is. It is. Mm-hmm. All right. Okay. 90 degrees. And you said this one was 4 and this one was 8. Okay. How do I find this one? Pythagorean theorem. So let's start. So I'm going to do black here. Okay. C squared equals A squared plus B squared, which means equal. Who cares? 4 squared plus 8 squared, which is equal to 16 plus 64, which is equal to what? 80. Obviously, C is equal to what? How much is square root of 80? Very close to the square root of 81. So almost 9, but not quite. So, yep, 8 point. What is the square root of 80? Okay, what's the situation for all the numbers that we have? Look at all the numbers that went into the problem. Um, what's like? What is the lowest number of significant figures in all the inputs? 2. So that means this needs to be approximated to what? To 2 digits. So, yeah, but remember, think about it this way: you always judge by the best accuracy or at least the worst case. Exactly, because you know then your precision cannot be worse than that. But you can never guarantee that it could be as good as the best. Yeah, you always go by the weakest link or the lowest one. So what would this one be to two significant figures? No, 9 would be just a single digit. 8.9, yes. So 8.9 and kilometers. Okay, that seals the deal for half the problem. Now, which angle am I supposed to find? The top one or the bottom one? And you have to tell me why. Why? You never find the angle at the what? At the end vertex. You always find it at the start. Perfect. Start. Oh, well, technically, you can just subtract from 90, 100%. But that means you're still going to have to do what? One extra step. So go ahead and put this symbol. What's the name of this symbol? Theta. The most famous symbol for angles. Okay. Technically, I just figured out this one. However, do we ever use the hypotenuse in our calculation? No, because it's not bad mathematically. It's bad what? Numerically. It's been rounded. I don't think we should base our calculations on a rounded value. So I always use which ones? The which one? Sorry? The tangent. So I use which ones? The exact ones that I gave you, which not all usual, happens to be always what? The opposite and the exactly. So in this case, this is my opposite, and this is my adjacent. So OPP and ADJ. All right. So tan of theta is equal to op over ad, which is 8 over 4, which is exactly what is. So is that my angle or the tangent of it? That's the tangent of my angle. Now my job is to find the what? What angle gives what? Gives a tangent of exactly 2. How do you always find that? You inverse, which means, by the way, here's the inverse on, I'll show you the inverse on my, everyone look up. If you're right, your answers are, I heard you 63. You're right. Everyone, if you have, how many people have a single display here, like the small calculator, for example, or even on your cell phone? See, on cell phones, sorry, single displays usually, you do not tell it, sorry, you give it the number first, and then you tell it what to do with it. In a double display, it's the what? It's the opposite. You tell it what to do, and then you give it the what? The number or the input. So, for example, in a double display, you would say shift tan, which gives the rise to what? Whenever you hit shift, what do you always get? The inverse. So tan inverse, and then you put in bracket the input, which is in this case just what? 2. In other calculators like mine here, I have to put what first? 2, and then I tell it what to do with it. So I clear, I put 2, I'll clear even here. I put 2, and then I go here to the trigonometry section. And do you see any inverse on any of these? No, they're the forward ones. I need the what? Backward. That's what the second button is for. You click it, and all of them become inverted. And yep, boom. How many digits do we need to keep again? Everything has been based on 2 at least. So that means what? 2. So it's 63 because the 4 does not touch the 3 and it does not turn them. So there we go. So the angle is 6. So that means, what's the statement though? I always want to see the correct statement. So what do you say? Theta equals, yes, theta equals tan of 2, which is equal to. You're right. Where you absolutely. Where's that? Does that make sense? No, you don't tan the 2. You what? You inverse tan the 2. By the way, what does tan 2 mean? 2 is an angle, right? No, 2 is the actual number. You need to inverse tan back. So please always remember these little things. Thank you. Okay, one last step. My final statement. Delta D for both of them, because they share the same displacement, equals, what do you start with first? Directional magnitude. Magnitude all the time. So it's 8.9 kilometers. And then what do you open? You always, and you never, do you open him here? Never. The magnitude is not a part of the direction. So here and here. How do you decide how you're going to actually what? Put the directions in order here. Remember, you start at the start vertex, and then which direction do you go first? Obviously, you can never go tilted. You can only go on the what? On the perpendicular direction. So which direction do you start once you start from the start vertex? You are going this way. So you have to go this way. And then you go what? north. Perfect. So you go west, then north, and in between is the angle, and voila, full marks. Yeah, what's up? No, okay. No. Okay. But to his point, technically, by the way, there are so many ways to indicate direction. By the way, you guys see a different. This is our way in physics 11. I'm gonna keep it the same to physics 12. The old Nelson book used to. Okay, everyone. When I taught 11, 12 years ago, the Nelson book did not used to say west 63 north. It used to say what? 63 degrees north of west. I always found that what? Confusing, right? Because you say north of, which makes sense. Because you go what first, everyone? You go what first? And then you go what? North of west. But the problem is then the one you say first is the one you travel last. Do you see what I mean? Never really been a big fan. When we got the new Nelsons, they adopted this one. So that's one way. How about if you take calculus grade 12? They almost never use this one. What do they use? Everyone, just watch this. Just 1 second with me here. How many people are taking grade 11 and 12 functions now? Okay. Whether you did or about to do, uh, you will do something. One of the most, I could say, one of the most extremely amazing inventions of the human mind, which is what's known as what is this? Yes, it's called the unit circle, which has a radius of how much? 1. So basically, everyone in grade 12 and even first university, you do not use north, west, south, east. You use the what? Look, you use the what? The x-axis, and you start from here. And which way do you go? You go this way. By the way, is that with the clock or against the clock? Welcome to what they call what? Counterclockwise. In math, counterclockwise is the way to what? To spin. Okay, is spin. By the way, whenever you actually want to tighten or loosen a screw, doesn't matter which way you spin. Of course it does. And what's the rule that we all say? Righty tighty, lefty loosey. That's actually based on this. That's actually based on the torque principle. The way they thread a screwdriver or a screw is actually based on this. Just such that if you're looking down and you go right, like to your right, if you're right-handed, to your right, you actually what? You tighten it. You go into the wood, right? And if you go left, you go what? You take it out. It's actually based on this. My point here is in grade 12 and first year, they will just say what? Oh, let's say my vector is here. What do you just go? You just go whatever angle you need. How much is this, for example? Let's say 6. That's it. You just say what? 60. You don't tell me what? North, east, west, south. You just tell me what? 60. What if your vector is here? You have how many choices now? What's the quickest choice? Even though, by the way, it's not the most common. They actually try to discourage you from it. Instead of turning up on the circle, you turn what? But there's a price here, just like going what? Just like going left on an axis. When you go left on an axis, what do you get? That's called a negative angle. Is there any such thing as a negative angle? It's not negative. It's negative according to what? To a turning direction. You see, we humans choose the reference. What's the other way to hit that vector without going down? Thank you. Exactly. You keep turning until you what? Until you hit. Can someone guess that angle? Well, let's see. 1/4 of the circle is how much? 1/4 is how much? 90. So you turn what? 90, 180, 270, 3/4 of the circle. Now, how much is this? Well, this one is how much? Which is how much is the complementary? 30. So how much is this one also? 30. So it's 300 degrees. Do you see what I mean? That is actually the way they program coding languages with mathematical software. Because you don't want to what? You don't want to be like, fixated by northeast. No. You set it from x-axis and then you go what? You go which way? Against the clock. Okay? You do exactly this stuff with calculus and vector. So that's basically it. Okay? Question for you. What if everyone, used this triangle? Not quite the same thing. By the way, two things that are okay. Consistent does not mean what? Identical. Consistent, but 1/2 and 3/6. Are they identical? Yes. Are they also consistent? Yes. Are those two triangles identical? Technically not, but are they consistent? Yeah, they make the what? The same two halves of a what? Of a box or rectangle. Can someone tell me if the hypotenuse is going to change? Sorry, the length of the hypotenuse. No way. By the way, what do you call the line that connects any four-sided shape or multiple-sided shape from one vertex, not to the next one, to any of the other ones? Starts with D. What do you call this line in a box? Diagonal. Thank you. And they share the same diagonal, so the hypotenuse has to be the same. However, is the traveling direction going to be identical to the first case? Not quite. Here, you went which way first? And then, if you're going with, that's why I always say, show me the triangle. You have to go what? And so those two would switch. How about this guy? It cannot be the same. It has to be the what? Whatever makes it to a 90 degrees, right? Like whatever is missing. What do you call that angle that is missing? Complementary. What's complementary to 63? 90 minus 63 is 27. So your answer then has to be 8.9 kilometers northwest with a 27 in between. Does that make sense now? Consistent, the same way. I'll leave it completely up to you. All right? Okay, perfect. So that's all we need to do for this one. Okay, everyone, let's flip the page and see the second part. What is the average velocity? By the way, which velocity are we never going to deal with? Instantaneous, because that requires calculus, okay, because it happens over an instant. So what's the average velocity in kilometers per hour of both Jack and Jill? Okay, let's think about this. Can someone remind us again, what is the definition of velocity? Or even the equation? What's the equation of average velocity, Yasmin? So that's the symbol, but what's the equation? What of displacement over? Did they both have the same displacement? We proved it. They both started the same, ended the same. Passive observer says they are, we assume they just beelined it this way. Time. Did they both take the same time to get to the end? Who said no? Okay, who said yes? You said no? Why did you say no? Actually, what does the question say? What the question actually says what? Amazingly, so when they both got to the end part, they actually got there when? Exactly at the same time. I'm saying, okay. No. Her question is legit. How? When we do the second part, you'll discover how. But just, no. She did not go faster. Trust me, you will be surprised. I love teaching physics because it really challenges your what preconceived notion and then makes you really see things in a whole different way. Hold on. Don't. I don't want to lose you here. Hold on to that question. Perfect question. My question here is: did they both have the same displacement? We start. Does the question say that they have the same time? All right. So do I need to do two calculations for the velocity? No. They are both going at the same velocity as far as the math is concerned. What's the definition of velocity again? What over what? So I want you to write same VAV. Just basically saying that you do not have to say what you don't have to do the calculation twice. Okay. So let's do the equation. V AV equals delta D with an arrow, please, over delta T without an arrow. By the way, just so you know, time is never a what? Time is a scalar, although it's a huge debate between physics and philosophers because they all say since time only flows in what? One direction, technically it has a what? It has a direction. But do we really care about that in grade 11 physics? Nope. Always pick your battles here. Okay. What's my displacement from the first page? 8.9. Okay. All right. I'll show you something here. Do not copy what I'm about to write. Obviously, can you do this? Long fraction, 8.9 kilometers, west north, right? Yeah, 63 degrees north. Over how many hours? Can you write that? Of course. No, can you? Yeah, you literally did nothing. You replaced everything with its own value. I just have one small issue with that. It's not much of a common mistake, but it happens. And if it happens once, I'll address it for sure. The problem is, many people, when they see that, how many numbers do you see on top? And is this a multiplication or a division? what do they end up doing? They end up dividing this thing by 2.5, and also what? Is that correct? Do you ever change the direction once you get it? Never. So what do I always do? The way I always write it is this way. I just put what on top of what? You exactly. How? By the way, if you divided anything by a number other than 1, what happens to that thing? Or gets bigger. Remember, because if you divide by a decimal, it gets bigger. So, but it changes. That's my point. Is it supposed to change? No, it's not, because the direction is still the same. They went straight from start to finish. So never change the angle. So, but if you write it like that, are you correct? Not fully. What am I still missing? I'm missing the direction. So where do I put the direction? Next to the fraction. Do you see what I mean? So I put the things that change together, and then I just put the direction next to it to just make sure it doesn't change. But I'm afraid that you might see both on top of the fraction and divide them both. No. Okay. Trust me. You do things for 12 years, there's method to madness. I am basing everything on experience. What's 8.9 divided by 2.5? Well, it's not 10, so it's not 10 divided by 2, but it's less than 4, so 3.56. However, everything is based on how many digits? 2. So what's 3.56? 3.6, because the 6 bumps up. So 3.6, what unit? Kilometer. Actually, remember, this is how I always give you a question. I will always remind you to put the unit. Kilometers per hour. Done. So that's the what? Velocity. Okay? Thank you. I was waiting for someone to say that. If you just say that, is that a vector? No, you lose half the mark. Perfect. Exactly. This one has got to stay with it. Perfect. Remember, vectors need a direction. Nice. Good catch. So their velocity is 3.6 kilometers per hour in the direction west-north 63 degrees. Okay. Now let's do the what? The second question. What's the definition of speed, everyone? It's what? Okay. Did they travel the same distance? Of course not. So we need to do how many calculations? 2. Okay. What is the distance, total distance, traveled by Jack? Go ahead, add up these 3 numbers, because he only had 3 stages. Okay. It was 10 plus what? Plus 8 plus 10 plus 8 plus 6 is how much? 24. Okay. Let's add the numbers for Jill. What's the number for Jill? How many people say, huh? How much? 20 what? There you go. Did you see what I did with that problem? I just gave you 2 people who seemingly traveled what? 2 different paths, yet what exactly? Thank you. Now, Yasmin, do you see why it took them both the same time? See, they ran differently, but they were both running at the same what? No, at the same what? At the same speed, apparent, because they both traveled the same amount of what? Distance in the same amount of what? You see how you can base a question that doesn't look the same, and yet every single thing comes out to be the same? It's how you build up the problem. Okay, so again, do we need 2 calculations? No, no, 2 calculations. They both have the same distance. They both have the same time. So they both have the same what? Everyone, listen up. Go ahead. But okay, question for you. When you add up their distances, do you still get the same answer? Do they both have the same time? So do they both have the same speed of running? Whoa, does speed have a direction? Why does speed have no direction? Because speed is based on what? This distance, and distance has no what? Do you see what I mean? Again, remember, when you go run around the track, okay, and you're done doing your laps, do you really care how you ran or how fast you were running. By the way, you never care how you run, because you're changing your direction every what? Every nanosecond you're changing your direction. That's why direction with scalars does not make sense. Isn't making sense now. Even though you might say, but they're running on different trails. I don't care. I care about the two numbers that judge whatever they do. Perfect. All right. So go ahead, everyone, and just say what? Same. What did we say here? Same. Yeah. Same VAV. Okay. So delta D. My bad. Delta D for both. I want you to write for both is equal to how much? How far? 24 kilometers. So that means V AV equals what? Oh, well, where's my mistake here? My bad. Sorry. On this mistake, force of habit. Delta D over delta T equals 24 kilometers. Sorry? No. Distance. Scalar. No more direction. Over what? How much? How long? Sorry. Which is equal to how much? Any I know. You're right. I shouldn't. Remember, I'm always gonna keep doing mistakes on purpose to keep you on your toes. You're right. You should not put this. Okay. So what's the answer to this question? Who's gonna win the race? They done. They still hate each other. No one wins. Okay. Everyone, you're in this. Okay. Do you have this? Okay. All right. Now, can someone tell me one difference between them for sure? Can someone tell me one difference between them for sure? What's one difference for sure? Velocity is a vector and speed is a scalar, which means one of them. Wait, hold on. One of them has a what? Okay, so that's the first thing. Okay. Question to you, everyone. Pencils down. Don't write anything. So write that and then stop. Write that and then stop. So my question is, what was the velocity we got for both of them? 3.6. Yeah, as a magnitude, 3.6 times that. What was the speed we got for both of them? Explain to me why speed is bigger than displacement. Don't shout it out. Just give it some thought. Raise your hand. By the way, there are multiple ways to explain it. All of them are correct. I just want to hear it. Okay, so y is distance. Sorry, y is speed. Why did we get a number for speed that is bigger than velocity? Who can tell us why? Yasmin, give us your interpretation of it. Hold on. Oh, hold on. Wait. Velocity. Velocity depends on. Okay. Okay. So Yasmin is saying that because velocity depends on displacement, but while speed depends on what? Okay. Speed has to always be bigger. Who has another way? You're right. Who has another way of saying it? By the way, I am not gonna give you a lot of communication questions in this course. Like I'm not gonna say part D, explain your answer or so and so. But sometimes I might. Okay, I'm gonna keep it to a minimum, but sometimes I might. Ali. Uh-huh. That's how it's done. Yes. Distance will always be a bigger number, which means whatever depends on the bigger number must be the what? must be the bigger number in the second calculation. Who would like to contribute yet another way? Okay, I'll contribute another way. What kind of observers are they? Passive. So let's think about this. Everyone, eyes on me. Jack and Jill are in front of me. Okay? I'm gonna be the passive observer. Omar's gonna be the active observer. So what does that mean? They start running from the same one, from same spot. What do I do as a passive observer? Let's say they're running on this side of the universe. I turn around. I turn around. I do not look back once. I'm not permitted to check the experiment. What is Omar doing? He is Hawkeye the whole time watching both of them, right? Okay, I'm still turning. How long before they tell me we're done? After 2.5 hours, what do? I turn back. Okay, they both start from here. That's the only thing that I share with Omar, right? That we both know because both of us were looking at that moment. I looked back. He kept what? He kept observing. When I looked back, what do I only see? That they were where? Maybe here. How long did it take them? According to both my watch and your watch, 2.5 hours. However, to me, what do I think about them? No, no, not only that. To me, they're not athletic at all. 2.5 hours, and all you could travel is how long? 3.6. Right. Okay, question. What is their velocity? 3.6 kilometers per hour, right? How far did they travel in those 2.5 hours, according to me? What's their displacement? What's their displacement? By the way, what did I see? I saw they were here, and then I looked, and they were there. How far is this distance? Eight. No, no, 8.9. So let's say 9 kilometers. In how long? Are you kidding me? And those people are training for a race? Do you see what I mean? To me, they're very what? They're very slow because it took them 2.5 hours to just travel how much? Do you know what's an average walking pace? If you walk, which I speed walk, if you just walk like this, that's 2.5 kilometers. Sorry, 2.5 miles per hour, which is how many miles per hour? Sorry, 2.5 miles, which is how many kilometers? 2.5 times 1.6 is 4. 4 kilometers per hour. 4 kilometers per hour. So in 2.5 hours, how much do you get done? 10. They only got how much? 8.9. So what does that tell you? Even the running is slower than me walking. Is it making sense? Who comes to rescue? Omar. What does he say? He's like, no, 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 Mr. Ramadan. They did not just go 9 kilometers. They went how much actually in space? They went how much? How much? 24 in 2.5 hours, making them how fast? What's their speed? What's their speed? 9.6 kilometers per hour. Go ahead, divide that by 1.6 for me. I know the answer. It's 6 miles per hour. 6 miles per hour, by the way, is very, very slow jogging. But still what? Still better than what? Still better than walking. Do you see what I mean here? I judge them very unfairly. Why? Because I did not what? I had no idea. To me, it took them 2.5 hours to just go 9 kilometers. To him, it's like, no, they did more than you think. Do you see the difference? Do you see why I love to call it active and what? Passive observer never knows what happened, so they always judge the what with the worst case, straight line. The active observer tells me, no, there is more longer distance than this straight line. That's why what? Speed is always bigger than what? Because distance actively observed is bigger than what? Displacement passively observed. Is it making sense now? There you go. See, I cared as a passive observer. I cared about how about only how fast they went directly from start to finish. Omar cared about how fast they went along the entire path from start to finish. So he knows that they definitely got what? Got more. When is the only case that me and Omar got report the exact same thing? If they legit did what? If they straight went from what? Start to finish, then we don't have any discrepancy or any difference. So which one is always bigger, if not equal? Speed. So which one is always bigger, vectors or scalars? Because scalars what add up. Vectors never add up. Vectors go from straight to finish. And that's a universal principle in any vectors or scalar calculation you ever do.